Welcome to The Explainer. Today, we're diving into something pretty amazing, a brand new alliance between artificial intelligence and supercomputers. It's being built to solve some of the world's most complex puzzles, and it's doing it at incredible, mind-bending speeds.
Okay, so here's how we're going to break this down. First, we'll look at the massive, hidden puzzles that basically run our world. Then, we'll meet the classic tool that's been used to solve them for decades. After that, we'll explore the breakthrough that's making it all exponentially better. We'll get into how it works, and probably most importantly, why it matters to you.
You see, our world, our whole society, runs on these gigantic, invisible puzzles. And for them to work, we don't just need a good answer. We need the absolute best possible answer.
I mean, just think about it for a second. How do you figure out the most efficient flight schedules for an entire airline? What's the single best way to route millions of packages around the globe? Or how do you distribute power across a national energy grid without a single drop of waste? These are huge challenges.
And look, these aren't just some abstract ideas on a slide. These are the fundamental operational problems that big industries face every single day. A tiny 1% improvement here can literally save millions of dollars and conserve massive amounts of resources. So how in the world do you solve a puzzle that big? Well, for decades, the gold standard has been a really powerful mathematical method. Let's call it our meticulous, brilliant detective. Its official name is Mixed Integer Linear Programming, or MLP for short. And its superpower is pretty incredible. It doesn't just find a good solution, it guarantees the one single perfect solution. No guesswork.
But, there's always a catch, right? Perfection, well, it comes at a cost, and that cost is time. For years, MILP was just too slow for many real-world problems. So people often had to settle for faster shortcuts, things called heuristics that only find good enough answers. Our detective was brilliant for sure, but often too slow to solve the case before the deadline.
Now, the progress we've made is, honestly, it's staggering. Thanks to way faster computers and much smarter algorithms, this method has already gotten about 1,000 times faster over the last couple of decades. But for the gigantic puzzles we're facing today, even that incredible leap isn't always enough.
So what happens when being 1,000 times faster still isn't fast enough? Well, this is where the really cool breakthrough comes in. Researchers are now creating a new kind of alliance, giving our classic detectives some seriously powerful futuristic upgrades. The solution really boils down to two key pieces of technology. First, you give the detective a rocket ship. That's the raw speed of high-performance computing, or HPC. We're talking supercomputers. And second, you give them an incredibly smart AI partner. This AI partner uses a technique called learning to optimize, or L2O. You can think of it like an intelligence analyst that has studied millions of past cases. It's learned to spot patterns and predict the most promising leads, telling our detective exactly where to look first. Okay, so how does this dream team, the super smart AI and the super fast computer, actually work together in practice? It really is all about combining intelligence with raw speed. The process is really elegant. The AI partner gives our detective a massive head start. It points to the most likely solution and even tunes the detective's strategy before the investigation even begins. Then, the detective takes that smarter plan and uses the raw power of the supercomputer to just tear through the case. And here's a killer bonus. The system can even predict how long the whole thing will take to solve, which is a total game changer for planning. And the results? They are absolutely dramatic. Compared to the standard way of doing things, this new alliance delivers a massive speed up. It uses the expensive computing resources way more efficiently, and it can predict its own runtimes with really impressive accuracy. All right, so this all sounds incredibly impressive from a tech standpoint, but what does it actually mean for us, for the real world? And really, this is the most important question of all, isn't it? Why should a business manager or a student or just a regular citizen, why should any of us care about making some mathematical solver faster? Well, the impact is enormous. For businesses, it means smarter, faster decisions. For all of us, it means less waste in our supply chains, more efficient energy grids, and better planning for complex public services. And maybe most exciting of all, it means we can finally start to tackle huge challenges that were, until now, just considered unsolvable.
And this really gets to the heart of it. This isn't just about a speed boost. It's a fundamental shift in how we think about problem solving. We're moving toward a future where AI doesn't just replace our best tools, but it actually collaborates with them to make them profoundly, fundamentally better.
So that leaves us with this final, pretty exciting thoughts. By creating these powerful partnerships between proven, classic methods and intelligent machines, we are really just beginning to scratch the surface of what's possible. What's the next great challenge we're going to solve? Thank you for joining this explainer.